Jason.
Jason is a student, a graduate student. He went to NYU and then to Stony Brook, which is a good school, good physics school. And so, but he's doing philosophy of science. So I'm saying that Aristotle, opened with Aristotle, had these four kinds of causes. And as a physicist, I really only know what Aristotle called the efficient cause, okay, which is like the ordinary, idea of cause, that it's a past cause, future effect. The flow of causation goes, to the future, from the past to the future. It's unidirectional. Technically, it's called retarded causation. Retarded in physics terms. And up until recently, I was saying that physicists only recognize that one cause. So that's why I forgot what the other three were. But the big revolution is the final cause now: teleology, destiny, purpose, sort of thing. And strangely enough, the metaphysics of Teilhard de Chardin, the Jesuit from the 20s, he was actually, the Jesuits had some pretty smart people, actually. They are the brains of the Catholic Church. And I guess Teilhard was, actually he was considered, he was like banned by the, they went before the Inquisition like Galileo because he's a heretic, because anybody who's smart is banned, right? He's a heretic. So, but in any case, it looks as though his intuitive ideas of what's called the omega point, with like the mind of God is in this future omega point, and we're all kind of going toward it, that is now basically, it seems to be maybe a correct idea. In a technical sense. I'm not talking just in terms of theology and metaphysics. I'm talking about hard quantitative physics that leads the machinery and stuff that you can test the ideas with. That it's that the universe may be literally created from the future. In other words, the Big Bang creation of the universe was, so to speak, almost like in the Bible, an act of God from the future. But God is like alive and well in the future. I'm simplifying a little bit.
Well, that implies a purposeful universe.
Well, who knows? I guess God does purpose. So maybe he's an egomaniac. He wants to come into existence. But in other words, that like the stroke of lightning backward in time, the Shazam, that caused the explosion, so to speak, of the Big Bang, of now a particular observable universe, that this was actually created from the future in what is called a globally self-consistent loop in time. And that concept is a technical concept in the Physical Review, and it was I independently thought of it, but also a guy named Igor Novikov, who's a professor in Moscow. The idea was he got the idea too, and then Kip Thorne, a fellow named Kip Thorne, who's the Richard Feynman professor at Caltech, also, he was in collaboration with Novikov, and they kind of figured this out, that if destiny acts, if there are future causes of past effects, then it happens in a self-consistent way.
You want to tell people to come in and we'll get started?
Yeah.
I don't mean to interrupt you.
Yeah.
Soon.
So that's the big idea of that efficient cause, and what's forced the idea of purpose in teleology and the intelligence, a kind of cosmic intelligence. What's forced that idea is the discovery of dark energy, only in 1999, totally unexpected, because the dark energy is like this cosmic anti-gravitational impulsive field that is like 73% of all the gravitating stuff of the universe, and it doesn't consist of particles in the ordinary sense, and nobody expected it to exist at all, and it was totally, totally took physicists by surprise. What happened, there's a couple of physicists at Berkeley, I forget where the other team is, maybe it's Stony Brook, I forget, these two teams of astrophysicists, and they're looking at what are called type 1a supernovae, which are, certain stars, they collapse, and when they collapse, they explode with a tremendous amount of energy. And there's a particular class of these stars that are called type 1a supernovae, and they're very, we understand the physics of them pretty well, so they can calculate sort of everything that happens with them, so they are standard candles, so to speak. You can sort of, if you calculate the energy from such a stellar explosion, the astronomers, they can figure out just exactly how far away it is and stuff like that. So the ways of calibrating the size of the universe. And so these guys are going through their calculations, their computer calculations, and this one team at Berkeley, they find there's something wrong here, because everybody thought, well, the universe begins at what's called a moment of inflation, and then the energy releases what's called a vacuum phase transition, and that releases a tremendous amount of energy, and it creates what's called a hot Big Bang, this kind of quark, lepton, photon soup, and then the thing starts cooling down, and matter, ordinary matter, is created. Protons and neutrons and stuff like that is created. Mostly hydrogen and helium are created. And then, what's that?
Sorry.
And yeah, turn off
your cell phone.
And
Broken.
so, but what they found was that, see, everybody thought, okay, the universe created a Big Bang, but because of the matter in the universe, because of the attraction of matter in the universe, that the expansion of space out of the Big Bang should slow down. That's what everyone thought, it was going to slow down. Okay. And then there was even Einstein thought, well, that the universe would expand. It's like the surface of a balloon expanding, and it would expand to a maximum amount, then maybe recollapse again, what's called the Big Crunch. Okay. And then there was the thought, well, maybe it would just keep on expanding without ever slowing down. But the point is, they had to find out how much matter there was in the universe in order to figure out what that was. And nobody really knew how much matter there was. Well, about 1999, with these NASA experiments, these space probes, and Hubble telescope and all kinds of other space probes, we began to get a handle. And it turns out that the amount of matter, ordinary matter, stuff we are made out of, the star stuff, atoms, the amount of ordinary matter is only about 4% of all the stuff that's there. 4%. It's like the top of an iceberg. Okay. In fact, the organized matter is only less than 1%. So we are this kind of organized, star material, the heavy elements, is less than about 1%. 3% is like hydrogen, these big hydrogen helium clouds, mostly hydrogen clouds, but that, in other words, proto stuff that hasn't condensed yet into stars. But 96% of the stuff that we know is there, because we can see it indirectly, is dark. We know it's not ordinary particles. This is a big thing. This is a major embarrassment for science. 96% is unknown stuff. Okay. So what happened was, here's what happened. So like in 1999, year 2000, around the turn of the millennium. So what they from analyzing their data, they say it looks, not only is the universe not slowing down, but it's accelerating. So the accelerating universe. There's this anti-gravity repulsion. So instead of the balloon reaching a maximum and then shrinking again, it's actually going faster and faster and faster and faster. It's called the accelerating universe. And what's doing that is called the dark energy. Okay, now remember I said there was 96% of the stuff in the universe is dark, but about 3/4 of that 96% is what's called dark energy, and it's this anti-gravitational field. Okay. The rest of it, about 1/4 of it, is called dark matter, and it has the opposite effect. But there's less of it. It attracts. It's just dark stuff. For example, if you look at our galaxy, there's what's called the galactic halo. At the center of our galaxy, there's like this big black sphere. It's like a monolith, and it's like this big black sphere, and we know it's there. We don't see it directly, so it doesn't emit any light. It's a very strange thing. We're able to tell by looking at the speed of stars, of solar systems, circling around this big black blob, big black spherical blob called the galactic halo. And in fact, if it wasn't for this big blob of dark matter stuff, whatever it is, the galaxy would be unstable, and all the stars, we'd be off on our own. What is that Wagner? What's that Wagner opera? The Flying Dutchman.
That's a good segue. So
we're going to do an official welcoming. So go for it, Richard.
So that when that tall, beautiful woman sits down there, that means it's time for us to start. So
that was the overture.
That was the overture to the Flying Dutchman. So for those fortunate enough to be here, so welcome to the Theosophical Society.
you.
Society was founded in 1875. This particular lodge was founded in 1901.
1901?
Yeah. We have three avowed objects that form a nucleus of the universal goods without distinction of race, creed, sex, caste, or color. Encourage the comparative study of religion, philosophy, and science. Investigate the unexplained laws of nature and the powers latent in sentient beings. Could we have some meditation music, please?
Sure. So I'm going to do, you'll just have to forgive my voice because it is what it is. But we had a man who used to come here, and he was a performer in vaudeville. So we have a tradition that we kept his songs alive. He sang practically non-stop. He would break out into song at any given moment and blast everybody away, because they didn't have microphones back then.
Don't encourage me.
Good.
I can do vaudeville.
You're at home here.
Okay, so we'll, if anybody here, some of us know it, so you're welcome, of course, to sing along. This one is, well, Richard requests this one, so I'll do this one. How do you account for space without object, time, or place? Without object, time, or place, how do you account for space?
We'll give it a
Whatever is here, that is there. What is there, the same is here. He who seeth here as different meeteth death after death. He who seeth here as different meeteth death after death. By mind alone, this is to be realized. There it's the same as here.
Did you do Gilbert and Sullivan in college?
You know, since you asked, I was embarrassed for years singing these songs, but I sang them to keep them alive, and then I heard Joe sing them on one of the videos.
Oh, that is a vaudeville song.
And
Oh.
him and his wife put it together.
Oh.
But when I heard him singing, he sounded so bad that I thought, hey, maybe I'm not so bad.
We have a brief invocation that we do, and then we'll have a couple of moments of silent meditation, and we'll get on to our speaker. Clear light is the source of light, lighted every one of humankind that cometh into the world. It is the radiance of cosmic consciousness. Yogins realize it while still in the fleshly body, and all humans glimpse it at the moment of death. It is the light of the Buddha, the Christ, and all masters of life. Then to the devotee illumines shines unimpededly. It is the Guru and the deliverer.
Zen meditation. Did you get it?
Okay. So I would entertain a motion to...
I move the business portion of the meeting be suspended.
Is there a second?
Second.
All in favor?
Aye.
Any nays? Any abstentions? This is how we've stayed in business since 1901.
Good.
So that brings us to the speaker of the evening. We're very happy and honored to have Jack Sarfatti here. I'm not going to go into a long introduction. We'll just say that he's a compelling voice.
Haven't been 86 from Trieste yet.
That's right. He hasn't been 86 from Trieste yet. He's a neighbor. And if you do, you can always come here.
Not many people are 86 from Trieste.
Oh, we know a few.
And the title of today's
A
talk.
once and future holographic universe.
So let's welcome it.
I heard a magic word, like a Groucho Marx, you say the magic word and the duck comes down, you get $100. But the magic word was cosmic consciousness. which of course reminds me of my late father, Hyman Sarfatti, who was kind of like a mystical Jew, and he was always seeking cosmic consciousness. Right, he was on his quest for cosmic consciousness, and in fact, he read all these books. I guess when he was a kid, and he said when he was a kid in Brooklyn, this is I guess the 1920s, or 1940s. Yeah, it must be the 1920s. He would pass by was a Christian Science reading room, and they had big. Yeah, he was like a little kid, 8 years old, or something, and they had this big Bible, and they would change the page, and so he would go every day and read a page, and so he read the whole Bible that way. And then when he got older, he would I guess study in them, but he started reading all the books, the Hindu books, and in fact when he came to San Francisco, because I was here, my brother was here, came in the 70s, and at that time we had what's called the ESLIN, the Physics Consciousness Research Group, with Michael Murphy and George Leonard and Werner Erhard and all these guys. But in any case, so we met all these the Tibetan lamas and Tarthang Tulku. So I took my father went with me to meet Tarthang Tulku, and Tarthang Tulku took a look at my father one day and said stay, and invited my father to stay with him for several weeks at the ashram there, whatever, in Berkeley. So they had this kind of thing going on there. So I guess we come, it's kind of in the blood. There is kind of this mystical thing, but he was always seeking cosmic consciousness, and strangely enough, this whole Teilhard de Chardin final causation, the omega point, that's okay. Like if you look at Stephen Hawking, Stephen Hawking's the guy in the wheelchair, and the Lou Gehrig disease, amazing he's able to do what he does. But in any case, if you look at his book, A Brief History of Time, it's sold many millions of copies, although it's hard to anybody to understand it. His later books are actually better. There's better editors. But he asks 4 questions at the end of his Brief History of Time, and he's saying, basically, what is the mind of God? Even though he's kind of doesn't believe in God, but he's saying, that this issue, is there a God? Is there a mind of God? So he's actually asking, is there a kind of cosmic consciousness? That book was written before these new discoveries I'm talking about, or maybe around the time before these new discoveries I'm talking about were really assimilated into the understanding. It takes several years. It's only in the last 2 or 3, maybe 4 or 5 years that's beginning to be clear. And here's the picture that develops. We have this. What's called the moment of inflation. There's this what's called the before the creation, before the Big Bang, so to speak. The universe is in some state which is, people have ideas about it, but it's speculative. We don't quite understand the detailed nature of, but it's a vacuum state. It's called a false vacuum. And everything is kind of incoherent there. In fact, it is sort of like Genesis. Everything is like turbulence. Everything is, there's no order. Everything's kind of, chaotic, stormy. And then what happens, but it's an unstable situation, and there is a fluctuation, and it's almost like boiling water, where the water be the false vacuum and the bubbles are sort of this the new vacuum, what we live in. And so there's what's called the vacuum phase transition, and this vacuum phase transition, a lot of energy is released, and that released energy, because according to Einstein, energy is equivalent to mass, so there's enough energy around that the particles, actually quarks and leptons, get created, and the various what are called mesons, various bosons. So a whole kind of stew, like this rich stew of elementary particles. You have what's called a quark-lepton plasma, and then everything cools. As space expands, it's like everything cools down. It's called adiabatic expansion in thermodynamics, and so things cool down. And then the matter we're made out of forms. So that was the standard picture, except that picture didn't work because we now find that there are these other forms of matter, that the quarks and the leptons are only, as I said, like at most 4% of all the stuff in the universe. 96% of it I'm reviewing a little bit. 96% of it is unknown stuff. About 3/4 of that is this anti-gravitational dark energy repulsive field, and about 1/4 of it is this dark matter stuff. So the question is, what is that? But now, so the picture that comes out of this, in fact, there was a woman. Where was the University of New South Wales? That's Australia. There's the University of New South Wales, and in 2004, a young lady named Tamara Davis. She wrote a thesis, and what she did, she took the best dark energy data, the best dark matter data, everything that was kind of known. It's called precision cosmology. With the advent of computers and electronics in the last 10 to 15 years, she took all these NASA data and did a computer model based on Einstein's equations, Einstein's general relativity equations, which is the theory of gravity. And so she calculated what Einstein's theory says given this new observational data with the dark energy, the dark matter, all that. And a very interesting thing, it turns out that, I'm going to now simplify it. Technically, for anybody who's a physicist here, it's called the de Sitter space-time is a solution, the future. But what happens is our universe evolves into what's called the de Sitter solution. And what that means is this. It's as if we are living in the middle of a double fishbowl. Right? Just imagine you're a fish swimming in water, but you're in a spherical bowl. Okay, you're in a spherical bowl, and just imagine you're a fish at the center of this bowl. Except there could be two bowls. This is what's called the past horizon, the past particle horizon, and the future horizon. And I forgot I have this thing here. Let me. How do I pay that page down? Oh, wait a minute. Let me get back to that. I was gonna. Let me get to the picture.
Did you say one of the present and one of the future, or one of the past and one?
Here we go. Okay, this is the picture here. All right. Now this is what's called. It's hard to. I mean, this is pretty technical, but just take my word for it. Here's the Big Bang. This is the moment of inflation, right? This is I'll call it the alpha point of creation. Can everybody see this? If you can't see it, get up, because otherwise you won't be able to get it. This is what's called it's called the conformal diagram, and time is like a picture of the whole history of the universe. The whole from the moment of inflation to the omega point, which is actually in the infinite future, but due to the magic of mathematics, a trick of a guy named Roger Penrose at Oxford, it's called the conformal transformation. So infinite time is collapsed down to finite time. It's just a mathematical trick, okay?
Does it fold upon itself?
No. Here's what happens. Here we are, so to speak. Imagine you're kind of an immortal god, and this is your world line. Okay, this is space is on the horizontal, time is going up the vertical, and this is so here's the point of creation. It's like 13.7 billion years ago is when the moment of inflation happened. That's calculated from Einstein's theory and the data. So about 13.7 billion years ago, our observable piece of the multiverse. See, there are many universes. We're just trapped in what we can see because we're limited by light signals. Okay. So what happens is this green dotted line, that's called the past particle horizon, okay? And what it is, the way you have to imagine, if you take a moment of time is like a horizontal line, and where the horizontal line, imagine a horizontal, here, this blue line here, can you see this? Mm-hmm. Where that line intersects the past particle horizon, what that actually is, it's a spherical shell. It's like a spherical shell of, I'll call it black light. It's like we're surrounded. It's what's called it's like the surface of a black hole. Except we're inside the black hole. It's not quite a black. It's called the horizon, and what it means is we cannot see anything outside of that particle horizon. But as we move forward in time, we'll be able to see more and more of the universe that's behind the horizon, and. So that's what's called a past particle horizon. So it's like a spherical barrier, but that we can't see anything in our past that barrier, okay? Because of the property of light, the way light propagates. We're assuming all we can know is from light signals. So anything that's emitting light that's beyond that past spherical shell, called the past particle horizon. We don't know what's there. But as time goes on, we begin to see a little more, some stuff we can see because it's changing. Things change. Now, symmetric with that is what's called the future, our future event horizon. Okay, our future event horizon. And that's something in our future. Okay, now, it turns out, all right, in fact, let me put it like this. You see the top, it turns out that there's an interesting correlation of these technical diagrams with the old mystical images. See, the Freemasons, and even with, guess what, Theosophy. Well, it's the Star of David. It really goes back to the Jewish, the Star of David. What is the Star of David? It's two triangles. Right, the two triangles. Well, here are our triangles. There they are. I mean, they're not quite. I mean, here's one triangle, and there's that triangle. In fact, wait, let me just go back. How do you go back on this thing? I want to go back. Oh, page up. Okay.
Yeah.
There we go.
There it is.
Yeah. Okay. Okay. First, let me. Okay. Wait, let me go. Okay, well, first look at the. Okay, Robert Anton Wilson. I know Robert Anton Wilson was a kind of weird writer who I knew. Kim Hughes. But look what Wilson has here. Look at his image. Look at the Freemason, the Illuminati symbol.
Yeah.
See the Freemason? It's just like. So that's the future horizon. In this Penrose, Roger Penrose's diagram. It's just curious. I'm being a little loose here, but you can sort of, I'm being Jungian, right? I'm sure I'm doing synchronicity, Jungian synchronicity. It's actually deeper than that. Because here's what it is. What is that? All the visionary prophets, all the visionary mystics, and everything. What they are doing, they are remote viewing the future. See. Because we now know there were these CIA experiments at Stanford Research Institute with Russell Targ, Hal Puthoff, and stuff I was involved with back in the 70s. And, for example, Russell Targ, as some of you may know, Russell Targ reported, this is an experiment done in 1973 or 1974, something like that, 75, during the Cold War. The Central Intelligence Agency is running these experiments from behind the scenes. And what they have, they give there's this guy named Ingo Swann. I think it was Ingo Swann. Ingo Swann is this artist, this kind of a weird guy. But he was very good at this remote viewing, so like Uri Geller and all that kind of stuff. And so the CIA gives him a set of latitude and longitude. And they ask him to, and this is reported by Russell Targ, and it's actually printed. And so they ask him, well, what does he see? He's a visual artist, so they just give him the coordinates, and he draws a picture. And he's a painter. He's like in fact, like a William Blake type art. So he draws this picture, and they send it to Langley and all these analysts. And oh, this looks like a burnout. See, what they didn't tell him. But they didn't tell him the coordinates was of a red Chinese nuclear test facility. In 4 days in the future, they were going to be exploding a nuclear bomb. He didn't know any of this. It's 4 days in the past before it happens. And what it shows is the CIA. It's as if the bomb didn't go off. It's called a dud. It's like a dirty bomb explosion. It failed. Okay, that's exactly what happened. And 4 days later, sure enough, that's what happened. So they have stuff like that. Okay. So the point is, this is evidence. I mean, this is serious evidence by an intelligence agency. And I know the guys who do. I mean, I'm speaking, almost not quite firsthand, secondhand. I know the people involved, so I know it's real, and it's not just it's not just fiction. So. In the same way, a lot of these, in the Bible, look, the Bible's full of prophecy, right? All the ancient writing, everything is prophecy. So these guys, they are remote viewing the same way Ingo Swann's remote viewing. They're seeing. So it's no coincidence, really, that these kind of memes, these archetypal images, are showing up before we had the physics. See what I mean? The poets are seeing it. Poets are seeing it, right? And they're seeing things. So this symbol here, that's exactly. This is the omega point on the Penrose conformal diagram. That's the omega point. And guess what? See, now there's a guy named Seth Lloyd at MIT. And we're not talking about flaky people. We're talking about full professors at the Massachusetts Institute of Technology. Okay, and they have shown that the horizon is like a computer. It's actually a computer. and it's computing. It's like okay. In fact, here's a picture from Seth Lloyd's paper. Wait a minute. By the way, that's William Blake. Okay, William Blake. See, that's the and that's God, right? That's